So today we're going to have a look at how to write vectors in a few different forms. So we've got vector form, Cartesian form, and parametric form. So the equation of a line in 2 or 3 dimensions can be written in 3 forms. The first one is as a vector equation. Now, the way we would write that is vector r will be equal to vector a plus lambda vector b. All right. Yeah, so that's the very general form. The lambda is just any scalar, so any number. We'll have a bit of a look at these in a minute, what they actually look like. Now, the parametric equations are pretty similar. So there's going to be 3 of them. So for a parametric equation, the x coordinate is equal to a1 plus lambda lots of b1. So we're kind of just expanding this one out. The y coordinate equals a2 plus lambda of b2, and the z coordinate equals a3 plus lambda of b3. And finally, the Cartesian equations, they're just a rearrangement again of the parametric equations. So what we can do is we can write x minus a1 divided by b1, and that's equal to y minus a2 over b2, which is equal to z minus a3 over b3. Now, actually, in the way we get this is these things are all equal to lambda. Okay, and I'll just show you for this first one in a different color, so you don't have to write this down. But the way we got that is we've got x equals a1 plus lambda b1. If I minus the a1 to the other side, I get x minus a1 equals lambda b1. If I divide both sides by b1, this cancels, and I'm left with x minus a1 over b1 equals lambda. All right, which is what we got here. And you can do that for each of them. And they're all equal to lambda, so they're all equal to the same thing. So let's have a go at writing these things out, because that was a bit of a, yeah, that's quite a lot of algebra just to see. So we'll have a go at writing these out. So we've got a point A and B. So the first thing we want to do is we want to work out AB, okay, the vector AB. So again, we've seen this before, but we take the second term, -1, and we minus the first term, take 2, 0 minus -1, and 2 minus 4. So the vector AB is equal to -3, 1, and minus 2. All right, so that's our vector. These two here are coordinates. So the first thing we're going to do is we're going to write it in, let's write it in a vector equation. So in vector form, we have, so I'm just going to write, vector form. We're supposed to write it in the form r equals a plus lambda b. So our r in this case is going to be x, y, z. For our a, we're going to use our starting position. So we're going to use our actual a here. So 2, -1, 4. Oops, 2, -1, 4 plus lambda, which can be any number, and our b is going to be our vector. All right, -3, 1, -2. Now you'll notice if you make lambda equal to 1, this x, y, z will equal our b. All right, so this here is a vector going from a to b, but we can expand that out or shorten it to get any point along a line that continues along that plane. All right, so that firstly, that is vector form. Now, our next one is the parametric form. I find this the easiest one. So once we've written out in vector form, we can just go straight down the line. So firstly, our x. So we're just looking only at the top row here. Our x equals 2 plus, this lambda can multiply into all of those. So 2 plus negative 3 lambda. Our y equals, we go to the next line, negative 1 plus lambda, because 1 times lambda is just lambda, and our z equals 4 plus negative 2 lambda. All right, and that's our parametric form. So we just read across our lines there. Last but not least, we've got our Cartesian form. All right, and remember we wrote those as x minus our a1, so it's going to be x minus 2 divided by our b, negative 3, which will equal to y minus 1, so y plus 1 over 1, which equals z minus 4 over negative 2, and those all are equal to lambda. All right, so there you go. There we've got our vector form, our parametric form, and our Cartesian form. They're all quite closely linked, but it's good that we can see this now and have a go at using them.